So let's practice converting them. In this example, we need to write down the first 5 terms of a sequence if Tn, or the nth term, is 7n minus 3. Now this is the second type. They've just given us a formula for the nth term, and it's not a recursive formula. It's one that we can just use to find any term. So what you need to think is, okay, well the first 5 terms, what are they? T1, T2, T3, T4, and T5. And you could set it out like this if you want to find your terms one at a time. And then that is your answer. You don't strictly have to write them one after the other with commas in between, but you could if you wanted to. So now subbing in 1 for n is quite simple. 7 ones is 7, minus 3 is 4. Subbing in 2, I've got 14 minus 3. Subbing in 3, I've got 21 minus 3. And I can clearly see we're going up by 7, just as you're very familiar with this straight line having a gradient of 7. As x increases by 1, y goes up by 7, and that creates that steep line of a gradient of 7. It's the same sort of concept here. So we're going up by 7s, and once you spot the pattern, that might be the quickest and easiest way to get your terms. You could then obviously write them out like this if you wanted to, and you've got your answer looking nice and tidy. This example is asking us to write down the first 5 terms of a sequence if we are given one of these recursive formulas. So we're given the first term, 14, and we're given a formula for the nth term, but it's always based on the n minus 1th term, so we need to know what that is first. So you'll see this, every time you get a recursive formula, they'll specify that n has to be greater than or equal to 2. So can you think why that is? Well, what will happen if n is 1? If we sub that in here and say, hey, if we put n is 1, we'll get the first term. The problem is that here it will say, then you've got the t1 minus 1, you've got the 0th term, and that sort of doesn't make sense. The first term has to be the first term. There is no 0th term. So this concept of the recursive formula relies on being given the first one and then a formula for the second and subsequent terms. So how do we do it? Well, let's just go ahead and write out the terms. We've got the first term, 14. Let's find the second term. Well, we sub in 2 here. So the second term will be the first term plus 10. And it's quite quick and easy to see that then we're going to get the third term, we'll need the second term plus 10. And so on, we're clearly going up by 10s. And so we've got 54, and we can go ahead and fill it in like this. Or we could write our answer with commas. And you could jump straight to writing it with commas if you want to, and you can easily see what the pattern is. This is just my thinking and my setting out for if I had one that was really tricky. This time we're given the sequence, we've got the first 5 terms, and we need to find a formula for the nth term, and we also need to try and write it as a recursive formula. So just as you used to find the rule back in about year 8 or year 9 maths, when you were looking at a linear equation, you can use the same sort of tools for this. So I will be thinking straight away, this is T1, this is T2, and even just, it's not silly to write these down above the terms and then think, how does this number 1 relate to the 8? How does the number 2 relate to the 11 and the 3 to the 14? Because we need to find a rule to go straight from that little number next to the T down to this one. And just as back in year 8 or 9, you used to look at these patterns more set up like this, where x is 1, 2, 3, 4, or 5, and you might have y being 8, 11, 14, 17, or 20, remember the method that you use to figure out the rule for one of these linear equations. What I do is I say, well, I can see that as my x's are going up by 1 every time, plus 1, the y's are going up by 3. So they're going up 3 times as fast. Now, you know that when you're graphing things on a Cartesian plane, if the x's are going up by 1s but the y's are going up by 3s, you've got a gradient of 3, haven't you, which is quite steep. We've got a rise of 3 and a run of 1. Now that tells me that I need to multiply these numbers by 3 to get them close to these. Now, good old strategy is go ahead and multiply them by 3. What do you get? 1 3 is 3, 2 3s are 6, 3 3s are 9, 4 3s are 12, 5 3s are 15. How do I now get from these purple numbers to the red ones that I want? Well, they all seem just a little bit too small. They're all 5 too small. So the pattern for how to get from this number to this number is I need to multiply by 3 and then I need to add 5. And my good old method of coming up with the equation then was to say take x, multiply it by 3, that gives you 3x, and add 5. Now, why am I talking about x's and y's when we've got a sequence and we've got t's? Because this is exactly the same skill as what you need, except instead of x's and y's, what we have here is we've got t numbers. So if this is t1, this is t2, t3, t4, and t5, then if you're trying to figure out what tn is, whatever you did to all of these numbers, 1, 2, 3, 4, and 5, to turn them into 8, 11, 14, 17, and 20, you need to do the same thing to n. What did you do? Well, the answer is you multiplied by 3. What's 3 lots of n? 3n. And then you add 5. And it's that same thinking that you use to come up with this that you can use to come up with your Tn formula. So then I'd write T, the nth term is, I don't need this, sorry about the mess, 3n plus 5. Now, before you move along, always check your own work. You can double check to see if it actually gives you the right sequence. Try it. Okay, if t was 1, I'd have 3 1s are 3 plus 5, that's 8. Perfect. If t was 2, that would be the second term. 3 2s are 6 plus 5, that would be 11. Sweet. You see it works for a couple, it's going to keep on working. All right, writing it in this other form now. Well, the first bit's easy. We know what the first term is. It's given to us. That's 8. So if we then want to find a little formula for how we get the nth term, if we have the one before, well, what are we going up by here? We're going up by 3s, aren't we? So if we want to find any term, we can just take the term before and we can add 3. Now, if you're looking at the nth term, what would be the term before that? It would be the one that's just one smaller. It would be the n minus 1th term. And you need to take that and add 3. So this comes across as a little bit more complicated, but once you think through the fact that you just need the term before and you need to work out what the pattern is, this one is a nice easy way of explaining what the sequence is doing. It's going up by 3s.